In this video, we will learn how to approximate the standard deviation of a data provided to us in the form of a histogram. Senioritis is a temporary non-fatal illness afflicting thousands of high school and college seniors every year. Its chief symptom is a desire to be doing anything but schoolwork. A possible measure of the overall seniorities in a high school senior class is the percentage of seniors who miss school on senior skip day. The histogram below summarizes some senior skip day attendance data from the past 24 years for one high school. Given on the horizontal axis of the histogram is the percentage of seniors who actually missed school on senior skip day. Based on this histogram, estimate the standard deviation of the sample of 24 percentages. Carry your intermediate computations to at least 4 decimal places and round your answer to at least 1 decimal place. We already learned how to compute, or estimate in this case, a sample mean for data provided to us in a histogram form. First, we need to find a midpoint that will represent each class. In this case, we have 32, 44, 56, and 68, and each of those midpoints will multiply into its corresponding frequency. So 2 times 32 plus 10 times 44 plus 4 times 56 plus 8 times 68. Now this entire sum has to be divided by the total number of percentages, 24, to get a sample mean estimated at 53. We say it's estimated because we are using midpoints of each class to compute it. Now it's time to find the estimate or approximation of the sample standard deviation. To do that, we're going to use a very familiar formula, but it will be slightly modified because we do not deal with actual data where all elements are listed one by one. We are dealing with grouped data presented to us in a histogram format. So we need to use the midpoint instead of actual each data element one at a time. So midpoint will represent each class, subtracted with the approximated sample mean we just computed. Make sure to square that difference, and we also need to multiply that result by the frequency of that class, and we continue like that with each class we have. Again, next one, frequency is 10, so 10 multiplied into the difference between the midpoint and the approximated sample mean. That difference must be squared. Continue with next class and the last class. Don't forget to divide the sum by the sample size, in this case sample of 24 percentages minus 1, and take square root of the entire expression. Let me now show you how to enter this on a calculator embedded into ALEKS. First, we start with the square root and opening parentheses and closing them in the numerator where the sum is going to be. Then divide that by 24 minus 1. Now I'm going inside of the parentheses that I already opened, and I start typing in each of those addends that are, well, somewhat complicated. So 2 times another set of parentheses, 32 minus 53 must be squared, plus 10 times another set of parentheses, 44 minus 53, which must be squared, plus continue like that. I'm typing 2 more expressions that will be added in the numerator. I'm using the keyboard of the computer to type 4, then times, parentheses, numbers, subtraction, and all of that. I just use the squaring feature of the calculator to do the squaring. Okay, don't forget we already typed in the denominator, and everything should be already done and be ready to compute. So check that you typed everything and click equal sign after that. So the answer is right there, and I remember that I need to round to at least 1 decimal place my final approximation, so I'm rounding to 12.4, and that seems to be right. There's one more thing I would like to mention. If you by any chance forgot how to compute the sample standard deviation, how to approximate it when data is given to you in a histogram format, there is a link in your assignment to list of formulas, and this formula will be there, so you can always reference this link.